All right, folks, this will be our next job. Let's open it up and take a look at this, and I will go over what we got to work with. I will say it's a Kawasaki, and I'm going to do some work on it, which may involve some machining, and may involve some thread repair, and may involve some potty mouth. But we will find out here momentarily, won't we? Seems like he did a really nice job packing it. Okay, let me bring you in a little closer. This is a cylinder head from a 1983 Kawasaki KZ1000-P, a police bike. So it is a J motor bike, and it has many, many problems. The main problem with this head is that it exists and is not in a scrapyard. There's a number of problems with it though. There's a number of stripped out threads on the cam caps that we're going to fix. We'll do that in the milling machine. That'll be later on because we have to do some valve seat work first. We may end up time sorting all of them. I need to take a close look at the spark plug holes, make sure they're okay. I will show you the bottom side where the main problem is at. This is the intake side, of course. So when you flip this way, this would be number 1, 2, 3, and 4. In fact, let's just turn it. So in this configuration, this is number 1, 2, 3, 4. Remember, it flips over this way, and this is the intake side. Number 2, exhaust. Okay, so that would be this one right here, was giving him major problems where he could not get a clean lap of the valve. He verified the valves are not bent, and he still couldn't do it after what he called like mega lapping or power lapping or something. That's about the time that when I was talking to him via email. Hey, I'll take a stab at doing something like this for you because I have the knee-way valve kit and so forth. He's done all the measurements on the valve guides and the valve guide to valve clearances and things like that. And he said that they're all kind of borderline. We're not going to worry about that. This thing's going to go back together as is. I'm not going through that hassle again. But what I am going to go through the hassle of is cleaning up these valve seats and recutting as many of the 3 angles, probably all 3 angles, maybe on all the valves with the knee-way cutter, the 30, the 45, and the 60 degree cuts. I got to look at the service manual and verify those numbers. Memory serves, Kawasaki was like 32 or so, I don't remember, but it's close enough as far as one of the relief cuts. And then we'll verify the valves are not bent and maybe even bring them down the road to my buddy's shop and give them a quick grind. My first thing I'm going to do though is I'm going to put each valve in. I'm going to see what the installed valve heights are right now and then write them all down. That is going to be really important to try to dial in. And that's where I had the most challenge the last cylinder head I did on that bike. So let's go ahead and take a look at the other problems which are on the intake side themselves. Okay, so apparently he broke not he, but the bolt broke off, the M6 bolt that holds the carb holders on number, what would this be, number 3 and number 1. And so I'm like, well, what do you do with that? He said, all I do is put a little spacer behind the carb holder itself to take up that space. This doesn't look all healthy either because it looks like somebody's used some sort of epoxy on this. That's cracked. I'm going to go ahead and get this install valve height done and written down, and then we'll move on from there and figure out what we're going to do. But we are going to get this head redone for him in one way or another, and that way it'll be working on the engine. Okay, so it's the next day, we're back, and what I'm going to do is show you how I do the install valve heights. And I went ahead and pulled out number 1 intake. And so we're going to use that to start off with. This is the tool that I made the last time I did this, which fits down inside these bores. It's specifically designed for a KZ1000 head. And this is exactly, and I mean exactly 2 inches long. So it's higher than what the install valve height should be. So we can reach down through that hole, holding the valve up against the seat, and measure that with a depth mic. Pretty simple. You deduct what you find on the depth mic from 2.0 and you come up with your installed valve height. I wanted to try and be a little clearer on this, give you a better visual representation. This is figure 3-37 out of the service manual, which illustrates valve installed height, or I call it installed valve height. So this is what we are actually measuring, but from the top down. Red dotted line indicates the tool, which is exactly 2.0 inches, sits above the valve as it sticks through. There is a relief cut in the bottom of that tool to clear the tip of the valve guide that protrudes into that bore. All I do is do a classic reach around down from the top with a depth mic and get the measurement. It's a little confusing when you're calculating out which direction it's in, because we're measuring it from the top, not from the bottom. You know, once you get your head wrapped around, it's not too bad. But just put a little oil on these valve stems. I'm going to go ahead and shove number 1 intake in, and then we'll go ahead and jam it up. I've got a piece of styrofoam underneath there with like a little rubber disc. That fits perfect up in the combustion chamber and holds the valve in place, but I can't find one. So we're just going to have to use that. So let me put some oil on it, and then I'll shove it up there and we'll try it. Let me see if I can find the hole. There we go. All right. We'll line up our little slug here. You know, it almost looks like the tip of the valve has been ground, to be honest with you. It's got a very sharp edge on it. Very little chamfer. Usually that's got a greater chamfer. So anyway, you just put your tool in. Yeah, you hear it slam down the bottom of where that spring seat sits. Naturally, you don't have the spring seat in place. And you just put your depth mic on the top. I find this to be a very accurate way of doing this. Okay, and the measurement we're getting on the depth mic is 0.5, a half inch exactly. So that means that the installed valve height is 1.5 inches. We subtract this from the 2 inches. Standard is 1.464 to 1.496. So we know that our standard as far as the height of that tool is 2.0 inches. Now let's say we go to install valve height, where we push that valve up into the seat another 10 thou. So instead of this being at 500, it's going to be at 490, because it's coming up further in relationship to the tool. Ergo, this is actually going to back off a little bit. It's going to contact sooner. Take 2.0, we minus 0.490. We're at 1.510, so we're really getting way far out of spec at that point. So right now this valve is into the seat too high. A couple ways we can address that. One of the ways is we replace the valve, and if all of them fall into that kind of, you know, circumstance, probably what I'm going to tell them we need to do. Just order valves for them from like Z1 Enterprises. The other way you can do it is you can cut the you can grind the top of the tip of the valve, the end of the valve. But I think I mentioned before, it looks like, in my opinion, that these valves have already been ground, because they just don't look unmolested on the tip. Just the tip, and just for a second. There's very little chamfer on that. It looks like somebody's ground these. So what we have to do is we have to measure the distance between the top edge of the keeper groove to the tip of the valve and see if that's within spec. And we'll measure it just with a pair of calipers. That's close enough. All right, according to the service manual, and this would be the dimension we're working with right here, this dimension A, the minimum after grinding is 4.2 millimeters. So we want to see what it is right now. So that's 0.165 in imperial. But we do have a little wiggle room here. And I think it's because of the I can tell you what the problem with this valve is. I didn't even see this before. I think that's the problem. Let me see if I can use a piece of paper. Show you the back side. There we go. I don't believe this is a seat problem. This would be a valve problem. Let's pull another one out and check that one. Meanwhile, I'll put this one back, but I have a feeling we're just going to have to replace these valves. Find number 2 intake and try that one. Well, I don't expect too much of a difference on this one. As you can see, we're pretty much in the same place. And, you know, grinding the face is not going to help. The material is just gone. Back this off a wee bit. That valve is jammed up in there. This one's 0.508. So again, we'll just do our calculation. You know, I can do it in my head, but I'll probably screw it up. So 2.0 minus 0.508 equals 1.492. Well, actually, we're a little bit closer, 1.5496, so that's not too bad. We're actually within the standard, but barely. So what happens is when I recut that seat, it's going to go out of spec, and plus, you saw what that valve face looks like anyway. So let me try one of the exhausts. I'll just grab like number 1 exhaust. We'll try that, and if it's just as bad, then I don't know, I'm going to do them all, but I'm going to, check them all, but I got a feeling right now I might as well just replace all the valves. I want to do 2 exhausts instead. This is the one that gave him the biggest problem, and he said he really did a ton of lapping on this. Yeah, this one's not going to be too bad either, 1.507, so it's going to basically come in around 1.492 like the other one did. But again, we are right at the end of the top of the standard here. And we take any more off of this and we're going to be outside the standard. So I'm pretty sure I'm just going to email them and say we need to order new valves for this. It's the most prudent way to deal with this. Meanwhile, I'll check the rest of them off camera. I got to start writing this stuff down. Okay, here's a final tally. So you can see right here, the only good valve is really number 4 intake. 1.486 install valve height. So we're right in the ballpark for the correct install valve height. Everything else is either out of spec or so close to it that it makes absolutely no sense to mess with these valves, especially for what they cost. So I'm going to go ahead and get online with him and or email him and say we need to replace the valves, just replace all of them. And what that'll do for us is that'll bring us to a point where I don't think there's any problem with the valve stem to valve guide clearances, just the way they feel going in. But there is obviously some wear on the valve stems. So that'll correct any wear because they'll be brand new, assuming they're within spec being aftermarket. We shouldn't have any problem when we cut the seats. Just a little bit of bringing these seats into spec because he's lapped an awful lot. Like I can see right now, this is what, number 2 intake. Let's zoom up on that one. I mean, the width of these seats are just absolutely way out of spec. There's no question about it. That's pretty wide as well. And we could kind of measure one of those if I pull that spec up. Yeah, the width of the seats for both exhaust and intake is 0.8 to 1.2 mil. And I don't know if I mentioned this before, this is a J motor manual. I'm not using the old manual. There are some differences between the cylinder heads on a older Kawasaki, AB Kawasaki versus a J. Excuse me, I got gas as usual, which converts over to 031, 047. So we'll set it like 035. See, valve and valve seat, you can tell that. 4 is width. So just in case you think I'm crazy, let's round this off to 40 thou. I mean, that's 40 thou right there. So if you do that, I mean, this seat is way, way too wide. Let's check the outside diameter. On the intake, it's 1.413 to 1.421. That's 1.413, so you can tell that that valve face is most definitely bigger. Not by a whole smidge, but let me flip this head around so we can see that valve a little bit better, that particular valve seat. We'll measure that again so we can actually see the damn thing now. So we're at about 1.413. Yeah, that is much bigger. According to service manual, what they want you to do is they want you to cut the main face. So you basically just skim that until it cleans up. And then they want you to cut the 30 degree on the top so that the valve seating surface will have the specified OD. So what we're going to do is we are going to cut this face just by cleaning it up with the knee-way cutter as little as possible. Put some blue on it, and then we'll cut the outside 30 degrees so it brings the diameter correct. And then with the 60 degree, we go in deep and we bring the face to the proper width. And I've had really good luck with that knee-way, and I haven't used it much, so I know the cutters are in good shape. So the main thing here is you get to a point where you're cutting these seats. He's already done a lot of lapping, so it's essentially taking material away from the main seat or the face here of the seat. That pushes your install valve height up a little bit because it pushes the valve deeper into this into the seat. Our aim is to bring that back out, and I think new valves are going to be acceptable, or at least new valves will be the best way to do it because of all that dishing that's gone on with those valve faces. The worst case scenario is we may have to touch the tips of the valve stems. I'll bring them down the road to my buddy's shop that's got the oil flood feed valve cutter and put them in there and just take the appropriate amount off. All I have to do is, keep the valves oriented in the right spot once I do this side of it. Then bring them back here and they should fall right in. The more you cut off of this, the closer you get toward the top of the valve retainer, the valve spring retainer. It could potentially release the keepers because it's pushing down the retainer. It would be the bucket essentially hitting that, which is why we did that shenanigans on that Mark II, but where I actually cut some of the, I cut some off the tops of the retainer. Hey, the thing still runs, so I guess it worked. I don't think we're gonna have to do anything like that on this one, especially with new valves. We're gonna have the maximum amount of material here to take off, and that would be only a worst case scenario. I got a feeling, based on how this is looking right now, I think we can just barely cut these to bring them true. Just clean them up with the knee way. Cut the other two angles to bring the seats into spec, and then do an install valve height, and then see what we got. Now, then we have to consider lapping them, consider any material loss rather from lapping them. I have like three or four different grades of valve lapping compound. Freaking He-Man coarse, wicked, like, oh my God, like 80 grit sandpaper coarse. All the way up to 500 grit now, and you can get some really nice surfaces with that. So that is going to be the plan. That 2 exhaust is pretty bad. Yeah, there's a lot of pitting in this one. Number 3 exhaust is about almost worse. But I know he said 2 exhaust was the one he had the most trouble with, and the valve wasn't even, when he started to lap it, it was only hitting on one side or one part of it. And he checked the valve for bending and it wasn't bent. Let's clean that up so some Dykem will stick to it. I just want to do the valve seat up. All right, 7mm dowel. Put a little oil on it so it doesn't scratch that up. There's a numerous dowels in there, but I know this one works. Don't gotta bang them in or anything. A good push in the bush. You don't really need any cutting fluid or anything, as far as I understand, on these knee-way kits, because they're carbide tips. But all we're going to do is just give this a nice light cut to start with. It's cutting, let me see if I can show you this. I'm not really sure if I can, but it just goes to show you how dished the seat is as well, because it's cutting on the outside extreme edge and the inside extreme edge. And that's, that's not good. So, not terrible, but it ain't good. So we're just going to do that main 45. Yep, we're starting to get some cleanup. Definitely hitting down here more than it is up there. But we are hitting around the entire circumference, so that's a really good sign. Yeah, pretty close. I'm going to finish this up and I'll be right back when we get done with the 45. All right, let's see if you can see that. Now there's still a little bit on this left side that it isn't cleaning up down lower, down toward the bottom. And I'm not really worried about that right now because we're going to have to put the 60 in there anyway and bring that seat to width. So we may end up taking that out anyway. So you can see we're looking pretty good. Over here it's really good. Over here we still have a tiny bit. I think you can see it, yeah. But it's down low, so that's fine. Okay, now they want us to cut the outside diameter and bring that into spec. On an exhaust valve, it's, what is that again? 1.216 to 1.232. This one is actually pretty good. Maybe just touch that 30. Again, it's one of these things where these angles are opposite sometimes intuition. Since we're at a 30-degree angle, a much less steeper angle as far as relationship to the top here, we're going to actually bring that diameter down because we're going to be cutting the outside circumference of the top lip of that seat. Yeah, that's going to be about it right there, I bet. This one goes quick because you're cutting on an edge. you don't have a lot of surface area. Yeah, I think we're right there, so we're going to leave that. Now you see that outer edge now? That shinier outer part, thin one? Okay, now we drop the 60 in and we bring the seat width to dimension. And that's got to be brought quite a bit because that seat width right now is probably close to over 100 thou, I think it is. This is not going to be the easiest thing to check, so I think I might get a pair of calipers set up with the proper dimensions so I can reach in there with a pair of calipers. We're also going to re-blue this. That way we can see it better. Okay, the first thing I'm going to do is put the 30 back in and touch that top surface so I have a line because I can't see it otherwise. There's our little space. And we want to measure from that first angle to the bottom, which I can see pretty clearly right now. Okay, now we'll get the 60 in. I'm sorry I keep hitting you. It ain't gonna take long to get there. I'm gonna keep working on this and I'll be right back. I'm close enough, I'm happy with that. We know the diameter is good because we measured that. And then this would be the thickness of it right there. That's about a mil, 40 thou. So yeah, I'm okay with that. Yeah, it's all by eye anyway. You know, close is good enough on this. On the upper part, it's hard to tell because it's thinner because I smudged some of the Dykem blue. But when you can see the Dykem blue start at the edge of that 30, and then it's being cut away by the 60, then you know you're in the right place. Just measure it from that spot. So yeah, I'm okay with this. This is a good cut valve right here. And we know it's going to be concentric to the guide. Take a look at it with all this crap on it. And this knee-way kit works very well. Just like the service manual shows, doing it by hand. See that shinier section right there? There's your seat. That's the 30. That's the 45. That's the 60. And that really looks nice. So I'm happy with that. It should lap in quite well with new valves. Since I showed you that, I'm going to get all the valve cutting done off camera. Got to do it anyway. And here's the thing, there's really no risk here. This head's not going to work the way it is anyway. And it's got a shit ton of problems with stripped threads. But there really is no loss on this one. If we screw it up in this area, I mean, there's no loss because the head's pretty much going to be scrap anyway. So if we can save it, then all the better. Now you saw me on number 2 exhaust. I kind of measured that up with calipers. I ended up doing a little differently on the rest of the valves. I made some tools up out of some Delrin, and they are reamed out for exactly the size of that pilot or that guide that goes down into the valve guide. I think it's called a pilot actually. And so it's nice and tight fit, snug fit. And then I left a little bit of the edge so I could actually see it. And this is the exact diameter that it needs to be for an intake valve, and likewise I made one up for the exhaust as well. So when the pilot's down inside there, and you put this guy in like this, visually see without any problems, any difficulty, the edge, because that's the Dykem blue is still there from where I cut that. Right now it's wiped off. But I can see that edge where I'm cutting that. And that way it gives me the diameter that I need. That's really your starting point. The inside of that 45 is not relevant as far as the diameter goes. That's controlled by the width of the seat. That's controlled by that 0.8 to 1.2 millimeter width. All right, folks, here we are. All the valves are now cut. All the valve seats are done. Technically, and I mean air quote technically, we have a 3-angle, not a grind, but a 3-angle cut on each of these valve seats. And I think it came out really well. I want to talk briefly about the process. Now this is the one we did on camera, this number 2 exhaust. What you do, of course, is you put the guide into the valve guide. This is your guide that you use for your tool. You put it in. This particular one is like 7.1 or 7.2 millimeters or 0.1 or 0.2, I don't remember which. But it's the only one that fits these 7 mil valve guides properly. And I look down these valve guides very carefully with a light first, make sure they're clean, blow them out. I did not measure them because the owner did. That's the variances that you can have with these that will impact concentricity of the seat to the valve guide. It's not necessarily your tool, although I did put this in a lathe and indicated it up to make sure that it wasn't bent or anything, which it's not. There is always a slight amount of variance with these tools though. The valve guide itself down inside there, if it's egg-shaped or it's got a taper in itself or something like that, then multiply any variances because of that. But I have used this before, exact guide, these exact cutters on different heads, and they work perfectly. And I assume rather at this point we're still going to have a good result in the end, which we will know once the brand new valves come in that I ordered, because we're going to have to lap those in, and we'll show you that as well, at least a couple of them. This is the same kind of a guide that they would use if you had it on a machine in an engine machine shop, if you could find an engine machine shop, that is. And if you watch them on YouTube, the ones that still exist, they have guides like this too, and the tool slides down and their machine, you know, really quick. They hit the guides, do the angles, done. The thing I wanted to mention about doing these old Kawasaki in particular cylinder heads, the install valve height is very critical. You can only grind a certain amount off the tip of that valve. If you have too high of an install valve height, and you can remember, if you remember from earlier in the video when we did those tests on the existing valves, is kind of an imperfect test because the valves are mostly dished, ergo they're going to be artificially high inside there. It's really easy to have a situation where you cut too much out of these seats. I have had that happen on that Mark II that I sent out of state up to New Hampshire, and they did a great job on the valve seats, but they cut way too much out of them, and then we had to do all those shenanigans. If you watch that video, you will see what I had to do. I think it's actually multiple videos. We did correct it, but I had to do some shenanigans like changing the keepers on the valves to custom ones that actually lower the valve spring retainer in relationship to the tip of the valve. Let me show you what I mean. Okay, so here's an intake valve. So here's a tip, just a tip, and just for a second. I think these have been touched up, to be honest with you. I think these have been out before. They do not look like a factory untouched valve. You have a certain dimension that you can only have between the top of the keeper groove and the tip of the valve. And of course, if you have to cut more off the top of here and you're outside that range, you can get these little keepers. I can't remember if it was APE or ARP that sold them to me on that Mark II, that shifts the direction downwards. So essentially the little groove in the keeper is higher up in the keeper, and therefore when it sits in here with the top of the spring retainer, it pushes it down a little lower. That's the critical relationship. And when the bucket sits on top of this, there is a little button inside the bucket. And so there's just a little bit, it's a little proud of the inside of this bucket when it's facing this way. If it's too close, if the valve spring retainer is too close to that bucket because it's cut too close up here, then you can actually have the bucket come down and touch the retainer. That pushes the retainer, I got gas, down the valve and releases the keepers. The valve falls into the motor, and then you have a catastrophic engine failure. So this is very critical. That's kind of why I'm telling you all this, because I cut them by hand with this knee-way kit, which I think is a great option for doing these. You have a lot of control over it. The factory service manual says take only the amount of material out that you absolutely have to, and that's it. They're very specific about that. You send it to an engine machine shop that's used to doing automotive engine cylinder heads. They're going to bang that thing down, and they're going to take way too much out. In this case, I only took out what I absolutely had to clean up the seats, and I think we're going to have no problem getting the new valves to come into spec. A lot of these valves, maybe not so much this one, but a lot of these valves, this one has a little bit, are dished. You see that? And so these are going to be artificially pushed up into the head anyway because of that dishing on the face. Now I can't even consider grinding these because it's so bad. And here's another factor you have to consider. The edge of the valve right here, this outside edge, is called a margin. And there's a spec on the thickness of the margin too. Now I can't exactly find that in the factory service manual for Kawasaki. I have seen it in other service manuals. I'm sure I could dig it up somewhere.
At the time of editing, I could not find any Kawasaki reference on the margin thickness. So here's a page out of the Yamaha XS11 manual. You see dimension D, which is the margin thickness minimum of 0.7 millimeters. This is just a comparative reference for you to show you that it does exist out there. I'm just not sure where.
But you don't want a sharp edge, especially on an exhaust valve and on the margin of the valve, because what happens is that's an edge that's going to get very hot because there's not enough material on the valve to absorb, at least the edge here, to absorb that heat. And I've read a lot about this. I'm no expert on it, but I think the main thing that the engineers are wrestling with when they design these, heat transfer. One of the biggest problems with worn valves that are not sealing properly, and just valve seats and valve faces that are screwed up overall, is heat transfer through the valve. What you want to do is you want to have this valve seating so nicely, number one, when you put it in, it shouldn't spin like this with your thumb, which this one doesn't, but it's an unfair test because that dished in head may be giving us a false sense of security here. You want to have this thing where it's seated nice because it's going to transfer heat in the combustion cycle. Remember, both valves are closed at that point. And then the exhaust valve opens, and that one in particular, the margin is really critical on it because if you have that really thin margin. Now, of course, this is an intake valve, so just kind of pretend it's an exhaust valve where that margin really plays a role. It plays a role in both valves, but particularly the exhaust valve. So when this thing is sitting in nice and flat and nice and square and full contact around both of these seats, the combustion cycle allows the heat to transfer through the valve and then go into the head. And with the exhaust valve, when that opens up and the valve gets super hot from those superheated gases going by it, then the valve closes and it continues to dissipate that heat back into the head where it can be shed into the atmosphere. And again, that margin and particularly the exhaust valve is really critical, because if it's too thin because you had to grind it so much, well then that's going to get red hot and damage the valve. And the heat's not going to dissipate that well because it's just so thin. There's not enough mass for it to be pulled through the valve, and then when it seats, ergo to be sucked into the head. Remember that aluminum has a really good ability to dissipate heat. I mean, if you try to heat some up with a torch that's aluminum, it immediately goes away if there's enough mass because it just sucks it right in. That's why it's such a good material for this application. The valve grinding may not be practical. That's why we have to replace these. A, we'd have to take too much off and it would narrow the margin too much. And then B, it would go too far up into the cylinder head and we'd be way off on our installed valve height. And then we'd have to cut this as far as the tip goes. Then this dimension would be off. And then we'd have to put those modified different keepers in to drop that down to keep the spring retainer away. It's just a cascading, screw up of problems as far as that goes. And you just don't want it. Okay, we got ourselves a dilemma, as they would say in Hollywood. Well, the objective is to time cert all these holes for the cam caps. That's 8 and 8, that's 16 of them. I don't even have 16 inserts right now, but I got some coming. There are 2 diameters of these holes on each 4, one slightly larger than the other. I'm not talking about the thread, I'm talking about the counterboard, because these are all sunk in there, these threads. They're not surface threads. 2 of these are accommodated for these locating dowel pins, knock pins, whatever you want to call them. This is one of them right here, so you can see that kind of slips in there. Bob's your uncle. And it holds those caps in alignment, which is pretty critical considering what they do. Hold the cams down. These do not fit diagonally the other way. These are the smaller size. All 4 caps have the same exact setup. On the larger ones like this, a Timesert insert, an M6 insert, because the head of it is slightly larger, you see? It's got a big head. Well, that head will not fit into the smaller one, but it will into the bigger one. Now down below inside these holes that are larger, and I want to try to show you on one of these up closer here. You see down inside there, it's got like a little shoulder. Right about there, you see? Now that reduced diameter in there, which again is for where the dowel pin sits down into, or at least the depth of it, so it sticks up the designed amount. Well, that also will not accommodate the head of a Timesert. So it not only will not go into these holes, it will only go a certain amount down, and that would foul this up when we try to install it. In order to use Timeserts, we're going to have to do two things. A, we're going to have to modify these other two holes slightly, enlarge them a little bit, which isn't a problem because they really don't do anything, and I'm talking only a little bit. And B, we have to modify these Timeserts a slight bit. As far as the head goes, we're going to have to turn that down a wee bit so it clears all that, but still has enough, you know, sticking out in the side essentially for it to be a place where it bottoms. In order to use Timeserts, the only way to do it, because these are recessed holes. I was thinking about this last night, and I'm thinking, you know, these are not surface flush holes. I wonder if that's going to give us a problem, and absolutely it does. Speaking of helicoils, there was one in this hole. I don't see any others. And I would have been happy to leave that one, because this is the exhaust side, this is the intake side. We have to do this in two setups because I don't have the X direction for it. So we're going to start with the exhaust because it's worse. Well, you couldn't screw an M6 bolt into it. It only goes so far, and at the bottom of the thread insert, it was screwed up. So that's no good. Well, what happened in that situation is if you power a bolt past that, it'll gall that bolt up, lock it up, and either not get it out again or damage it or damage the hole or both. So this has to be right. We can't screw around with this. So it's either A, I go out to, all these letters here, A, I go out to the store like Auto Parts and get a crap load of M6 helicoils and just throw them in, or B, we got to do some extra work, fairly high degree of precision to get this right in order to use Timeserts. I want to use Timeserts. We got nothing to lose. We've already done the valve work, of course. We'd lose that if we scrap the head because of this. But I've done this before. I have modified Timeserts to go into certain spaces, and I have never had a problem with it. I've only done it a couple times, so I'm going to do it on this. Now, I checked these holes that have the dowel pins in them, and they're around 8 mil. They probably actually are 7.9. because I can't really get an 8 mil end mill in. However, said the wife, I can get a 5/16 end mill in. 2 flutes, brand new basically. And this goes in here just perfect. So it's basically that size. We're going to end up opening these holes up to that 5/16. It's not going to cause any problem at all or do any damage. We're just going to open them up to the appropriate depth. I'm going to do that with a depth mic. We'll just be able to pick up off here and go down the appropriate depth with the DRO. Problem solved. Then we can get our Timesert in even with the modified head. Even without the modified head we could on those. In fact, on those we probably don't have to, because they will fit inside these holes. And there will not be a reduced diameter section down below there, so we'll just probably leave them alone. We don't have to do all of them. See, the way a Timesert works is you're supposed to use a counterbore tool. That's the other problem. And you use a counterbore tool to accommodate for this little flange that I was showing you before, that little part of the top of this head of the insert. And that brings it down flush to a surface. Well, we don't really care if it's flush down to a surface because these are all down below. So we're going to have to do some shenanigans here to get this right. I've done all this kind of stuff to make things work. The other issue we have here is we have a depth certain. We cannot go down below a certain depth here. It will break through either outside or inside into a different part of the casting, which I don't think would make it happy. Whoops. So we're going to make sure we make that measurement as well, and we'll do the same thing with the Z-axis of the DRO. Now I've already taken the liberty of squaring this workpiece off. That way I can get it it's just easier to line up the holes if the head is straight. And I got it within 2 thou, so I'm good. Now I'm going to use this. One side is already at the size that the pin, where it goes in the pins, which is basically 8 mil, 5/16, close enough. The other side I just turned down to 290.290, and that fits in there. So we're going to put this in the chuck. We'll just locate off roughly, back it up with the indicator, and then we'll have an exact location over each one of these holes. Yes, it's a lot of work, but I think it's going to be worth it. Well, I think that's pretty close, half a thou, because this is a tenths indicator. Almost a thou there. It's good to me. Okay, I've got these holes mapped out using the SDM function, sub data memory function on the DRO. So I've got 4 SDMs programmed in, and the holes are labeled accordingly, 1, 2, 3, 4. If I do each set of 4 the same way, set them up with the SDM right out of the gate, then I can just work on those 4 and just move around. Do the various operations, and then pretty much after the inserts are installed, which I'll put in by hand with a tap follower, so that way we have it lined up really well. So yeah, it's the first time I'm using the SDM actually. It's pretty cool to use it. So let me get you set back up and we'll start a drilling. I also have my depths for both the counter bore, that end mill, and the drill for the time cert tap. Okay, I have a Z set, the tip of the drill onto the top of the casting. I'm going to go a depth of 25 mil or 1 inch. Total depth of that hole is about 1.100. I could go just a little bit more than the insert length, but if I do that and there's threads remaining in there, since the bolts are longer than the inserts, there's no guarantee those threads are going to match up and they're going to get all fouled up. You got to take the old threads out below where the bolt is going to go through the insert and essentially be in an open area. He gave me some longer inserts. Plan on using 9 mil, and I know I ordered a bunch of them. I'll see what I got in my stash and use some of his as well. Maybe we should use the longer ones, I don't know, but so I may end up having to reorder them. Let's put some lemon juice in here and we'll go to drilling. Wish me luck. One of these two here virtually had no threads left in them. All right, the next operation is use that 5/16 end mill, and we're gonna open up the other 2 holes, the ones that don't take the pins. So make sure I don't screw it up, I put a pin in. These diagonal ones have the pins, and then these 2 would be opened up. And the depth is to where the threads used to start. Now there is still a certain amount of thread there, and it remains, and it'll be more prominent once we really bore this out, counter bore it down. But I checked the other holes as well and made sure I had the right depth. And then this will accommodate, again, clearance for the tap to go through, because right now it won't. The insert, once we modify a couple of them, which I haven't done yet. So I'll just set the Z on this. We're in SDM 3 still. We'll just go down the set amount, which I think is like 365 thou. I need to double check that. 360. Now we'll go over to SDM2 and do the same thing. I'll do that off camera since you already saw it. Okay, tap follower is in a collet, and I had to set my heights based on this. Let me do the rest of them, moving around with the SDM. Okay, we're over at the lathe. I've got an M6 insert. This is a 9.4 millimeter long. Anyway, the head of these things are 0.312 or 5/16, or 8 mil, depending on how you look at it. Now, the way this works is these will not screw on any more than you see them right here, because this part of this insert is narrower. Because when you insert them with the insert installation tool, which you must oil, the tool, not the outside of the insert. We're going to put some Loctite on that. It spreads it out and helps it hold in the hole. And then you have a clear passage all the way through with a fastener. We use this to our advantage. It ain't going to screw up onto this mandrel, if you want to call it that, any further. So I calculated out we need to bring this down 32 thou to about 280. Touch off on it. There we go. I'll set a 0, leave it right there. Oh, we are touching it. Well, it's running out a little bit, we're touching it. So let's back off a little bit. All you gotta do, just like that. Break that edge on the insert, give it a twist and it comes right off. All we have to do is go make sure this fits. And it is still a little bit larger than the threads. It doesn't need much. You don't even have to do this, actually. You could run it in with some Loctite and let it sit, but you know, it would stay. But the best thing to do would be to have it bottom out in a hole. Now the only holes we need to use this on are these two guys right here. The ones that have that reduced size in there for the dowel pin to sit on. These two we're just going to put inserts unmolested in because it doesn't matter. They'll sit just down on top of that little ledge. All right, it's a moment of truth. These two holes are cleaned out. We'll do the back one first. We're loaded up on the tool with some oil on the insert for the insert. Assuming that my calculations are correct here, because I'm putting some Loctite on it and we're going to send it. You know, worst case scenario is we can machine it back out. So we'll use one of our Lyle tap drivers on this insulation tool, and if it screws up, it's your fault. You keep going until it starts to ease up. Just about right there. Good. Plus a little bit. Hopefully, this son of a bitch went down far enough. And it did. It looks beautiful. I'll show you. Okay, you see that little line? That is the line we want to remain and the insert down below of for that dowel. And there's your good threads with, you know, clearance down below it. And these two here don't need to be modified at all, so I know they will work. If I'm not mistaken, the torque spec in the service manual is wrong. I think they have a much higher torque spec than what these things really should take, you know, because it's going into aluminium. And I think that's why they strip out so much. It's something in the back of my mind tells me that, as far as in my memory. So basically, that's my story. I'm sticking to it. This is what we're going to do. Between today and tomorrow, I'll get all these holes knocked out. And by then we should have the valves in stock, and we'll switch back over to doing the valves. And once that's done, we're going to pack this bitch up and ship it. Alrighty, so we are done with all the machining work that needs to be done on the top of the cylinder head as far as all the thread repair. That's on these cap locations. I have all the time-cert inserts installed except on these 4 over here because I'm out of the 12mm ones. The first one that I did on the exhaust side, I forgot which one it was now, I put a 9.6mm long insert, and the cap torqued up no problem to 105 inch-pounds, which by the way is like 8.8 foot-pounds. And that's really the torque spec, that's what it's supposed to be on these, not 12 like the service manual says. Everything's torqued up fine. I've checked all 3. Now I had a major, and I want to emphasize major, mistake on this number 4 cap in between 3 and 4 intake. And I want to show you that because I don't hide from my mistakes. I'm talking about a mistake that's like parts scrapping mistake. But I managed to recover from it. Not really the best job in the world, but it is going to work. Now you know from previous clips my operations on the 2 holes that are not the ones with the knock pins or the locating pins. I'll go ahead and put 2 of those in here. So these 2 need to be plunge milled out to a depth of about 370 thou with a 5/16 end mill, which is roughly 8 mil, to open them up a little bit so the tap, the time cert tap will actually fit down in there. Now yesterday I got interrupted because I had some service workers here working on the home alarm system. They were actually supposed to come today. They came a day early. I was actually moving over to do these 4 holes, but I'd already picked up on one of the holes and set my first SDM. And then this morning I went to the other 3 and I set SDM 234. So I had mapped it out just fine. That wasn't a problem. So this is the first one I set up for SDM 1 right here. What I did was I set up the end mill. I touched off on the top, set the Z on the quill, on the DRO, looked at my notes, and ended up going down 1.1 inches. I just kept plunging.
I made you a little drawing to show you what I did. On the left is a normal counterbore with the threads remaining. On the right, I just plunged all the way down and absolutely destroyed all the material below.
That's the depth of the drill that I need to put in there, the time cert drill. I don't know what I did. I don't know why I did it. Wires got crossed in my brain, and it just didn't occur to me until even after I removed the end mill and said, what the hell did I just do? I plunge milled out all the material in there that would be necessary to drill to put a time cert insert in. There is none left, or was none left. Naturally, I had a heart attack at that point and had to go inside for a while. I mean, literally, my heart was like coming out of my chest, and I got blood pressure problems. It wasn't a really good morning for me. I thought about it for a while. I sat down and kind of just said, let me think about this and not jump into some half-assed solution. After doing some measurements, I realized that 5/16 is the tap drill size for a 3/8/16 thread. There's no metric thread around that size. That is the tap drill size would equal like 8 mil that I could actually put here without breaking into the bore here for the radius for the actual bearing for the cam. So I said I'm kind of stuck with that because I got to put something in that's got some sort of thread. So that's exactly what I did. But first I made a 3/8/16 plug with an M6 by 1.0 thread in the middle of it on the lathe. I cleaned the crap out of everything, Loctited the shit out of everything, and I put the hole a little bit shy so I could use a bolt to actually drive this plug in, this insert. And it worked. I got it all the way in. The threads are not as tight as I would like. They went a little bit on the bigger side because it's kind of hard, even when you're starting in a lathe, not always the most accurate thing. I have some pretty good M6 taps as well. They're USA made, like Drill America type stuff. In retrospect, what I should have done is probably made this insert out of bronze. All right, so next morning, and I could not leave that. That insert was well below my standards as far as what I normally would crank out. Right now I have it on the end of a little tool I made to get it out, which is a little sleeve. I'll show you this thing. Just a little sleeve on a bolt with a nut. It's a Allen cap bolt, stainless. And I was able to go down inside here, lock it in, a little bit of heat from the back side here with a torch, just enough to soften that red Loctite. Not a whole lot. I didn't want to heat this too much. I'm really kind of paranoid about distorting any of these bores, but I didn't put a lot on it to do that because the heat can go directly in right here. Luckily, I got a nice surface that's going to wick that heat right in, which is what it did. And I was able just to back this out. I'm really embarrassed that I even put this in the first place, to be honest with you. They're just terrible. I just didn't get good angle on the threads because of the material, I guess. So I ended up making a new one. I made it out of bronze, which is what I should have done in the first place. Let me zoom you up here so you can see a little bit better. So you can see that there's a bronze insert in there now, and those threads are beautiful. Absolutely beautiful. I'm also liking the fact that the height of it, I made it a little bit longer, which you have to do on these kind of things because you're going down to a bottom of a hole. Even with a bottom tap, you can't really get the threads all the way to the bottom of a hole. And in this particular case, on this one, as you can see, I put some relief in the bottom of it so it wouldn't foul at the bottom and it would go all the way flat. I ended up putting this bronze insert in here, if I use the old one as an example, with this tool, and was able to really give it a good crank, you know, down in there with a bunch of red Loctite. And so it's seated in nice. You know, I clean the threads out with that tap again. Anytime you go into aluminum with a tap more than once, it takes a little bit of material. So I didn't want to go cray-cray and washed it out with brake clean, but that is so much nicer. And it does work. These bolts are all a little bent. I'm not surprised. We got new ones coming. This is so much nicer. I mean, I'm gonna pop the cap on and show you here how it fits, because it fits great. This is the hole we just did with that bronze insert. She's got some, these bolts are bent because I was dead straight on everything. But anyway, you get the idea. It goes right down. There's probably just a little bit more space down below that bolt where the thread is, because I made them pretty deep, you know, deep enough, but you can definitely get a torque on this. I will try it later off camera. Really going to be a very solid repair for this ridiculously stupid mistake that I made. Which, by the way, bronze is a great material for this because it's much harder than aluminum. It's not steel, but again, it's way harder than aluminum, and it's going to absolutely never pull out with that much thread engagement. But with bronze, you can just run a tap straight through the damn thing, which is what I did. Now, when you get these new valves in, you definitely want to check these to make sure they're not bent. I put them in a lathe and spin them up. If there any wobble at all, I'll put an indicator on them. This one did not wobble. Alrighty, out of all 8 valves, 4 intake, 4 exhaust. This is the numbers of these new valves right here below this line. The only one that gives us a problem is number 2 exhaust. Okay, so I'm lapping valves now. I haven't gotten to number 2 exhaust, but we will here shortly. I've done number 4, number 3, and number 2 intakes. Here's number 3. You can tell because it says 3 on it. And I could not be happier with the width of the witness mark as far as the width of the seat. But the only other thing to do then after this is to give this a really good clean off camera. And then we got to get the valves back installed. And we'll fill the combustion chambers up with alcohol. I like to use isopropyl alcohol instead of gasoline. It's safer. And we'll let it sit. See if any dribbles through. If it does, we got to pull that valve out and lap it a little bit more. But the way this thing looks right now, I have a really strong feeling that we're not going to get any leakage whatsoever.